Uh, Hello and good day. I'm Luyan Pakana from Group 12, and I'm here to report our topic, network trouble. The first up is network documentation. So let's start. Documentation overview. As with any complex activity like network troubleshooting, you will need to start with good documentation, accurate and complete. Excuse me. Network documentation is required to effectively monitor and troubleshoot networks. So, common network documentation includes the following: physical and logical network topology diagrams, network device documentation that records all pertinent device information, and network performance baseline documentation. So, all network documentation should be kept in a single location, either as hard copy or on the network on a protected server. Backup documentation should be maintained and kept in a separate location. This documentation is very essential to network troubleshooting, since when a network problem occurs, these three that I have mentioned will give basically information on how to respond to a network problem in the network. So as these three also, I will be also discussing in the following. So first up is network topology diagrams. So network topology diagrams keep track of the location, function, and status of the devices on the network. Basically, there are two types of network topology diagrams, which is the physical topology and the logical topology. So first up, let's start physical topology. Excuse me for having a bit of a hard time navigating, since I'm only using a cell phone. So a physical network topology shows the physical layout of the devices connected to the network. You need to know how the devices are physically connected to troubleshoot physical layer problems. Information recorded on physical topology typically includes the following. So device name, device location, interface, and port use, and cable type. So basically, physical topology is how physically the devices are connected together and when are they connected as well. So we have so these are the four needed information that needs to be documented, which is device name, device location, interface, and ports use, as well as cable type. Let's go to a sample of physical network topology diagram. So as you can see here, it's basically a network with relevant information on devices, the cables, and etc. So let me just scroll down here. Okay, so basically that's a sample of physical topology, physical network topology. So next is the logical topology rather. So basically, in here, a logical network topology illustrates how devices are logically connected to the network. This refers to how devices transfer data across the network when communicating with other devices. Basically, the information recorded in logical topology is device identifiers, IP addresses and prefix links, interface identifiers, routing protocols, static routes, layer 2 information, sample is VLANs, trunks, and Ethernet channels. So let's see here an example of logical topology. So here is an example of a logical topology, which is IPv4, by the way. So basically, when you go to work, you need to familiarize physical and logical topology, or document it if ever there is no physical no documentation, because sometimes there's already documentation on the network, but if it hasn't, when you're in work, when you when you know that there's no documentation, you just simply create a documentation yourself by creating physical topology and logical topology. So next is network device documentation. So basically this is how you should document all different devices information. So here are the tables, the interfaces information, the model, description, location, iOS, and license. So this is basically the right way to document the network, so you can have a easy go of getting information from the network. So let's see here as well. So the ports, this relevant information about the ports. So description, access, VLAN, trunk, Ethernet channel, native, enabled. So basically that's how you should follow this format on documenting router information, port information, and etc. So now we go to establishing a network baseline. So the purpose of network monitoring is to watch network performance in comparison to a predetermined baseline. To establish normal, a baseline is used to establish normal network or system performance to determine the personality of a network under normal conditions. So basically, a baseline is you basically want to monitor your network on what is normal and what is abnormal operation, or also network traffic as well. So a network baseline should answer the following questions. Basically these are the things that will be answered when you create a network baseline, so or establishing rather. So a network baseline should answer the following questions: how does the network perform during a normal or average day? Where are the most errors occurring? What part of the network is most heavily used? So these are basically samples of what establishing network performance baseline answers. So basically it's like a monitoring system in the network in which it checks or monitors the network with regards to the normal operations as well as the traffic. If basically there's an traffic or abnormality in the network, you basically will know that there's an abnormality, and so in which because of that you can respond or basically know that there's an abnormality, and then you can respond to that abnormality or traffic, so there will be no more problems in the network and it can easily be solved faster. So here is measuring the initial performance and availability of critical network devices and links allows a network administrator to determine the differences between abnormal behavior and network performance, as well as network growth or traffic patterns change. So as I've mentioned before, these quotes here or these sentences here, in short, is basically you monitor the network, its operations, its network performance, traffic patterns, because of this you may notice hidden changes in the network which may lead to problems in your network. So this network baseline is very essential in network documentation because it monitors, again as I've said, it monitors the network operations, abnormalities, and traffic. So step 1 in creating a network baseline is determine what types of data to collect. So basically is you select a few variables that represent defined policies, and also you start with an interface and CPU initialization, so you can use this baseline to monitor traffic. Also checks when an abnormality appears in the network. So basically this is how you know what type of data to collect. So next step would be identify devices and ports of interest. So basically, you will use the network topology to identify those devices and ports for which performance data should be measured. Device and ports of interest include the following. So network device ports that connect to other network devices, servers, key users, anything else considered critical to operations. So the network topology that we will be using here is logical network topology, since basically it can be useful in identifying key devices and ports to monitor. Logical topology is suitable in this step 2, since it can identify ports and also identify key devices and monitor them basically. So here, as you can see in the topology here, this topology is basically a logical topology. It monitors the ports here and also identifies the key devices. So next is the most important step is determining the baseline duration. So the length of time and the baseline information being gathered must be long enough to determine a normal picture of the network. So it is important that daily trends of network traffic are monitored. So basically, this is the determining factor in which you will notice or monitor how your network runs, and also how the duration, what duration must it be. So it is also important to monitor for trends that occur over a longer period, such as weekly or monthly. So for this reason, when capturing data for analysis, the period should at minimum 7 days long. So baseline duration should be as said here, minimum of 7 days long. So lower than that is not optimal. So here are the examples here. CPU this is the CPU utilization. So here first is daily, so hourly here, and a day. So these are examples of monitoring. So next is data measurement. So basically this is the last part. Before we go here, as we have mentioned before, so the duration of baseline is basically essential also, since you could also miss some monitoring, like for example is the duration of monitoring. There may be hidden problems that you may discover if you set the duration of the baseline right. So last is data measurement. So when documenting the network, it is often necessary to gather information directly from routers and switches. Obvious useful network documenting compliant ping, traceroute, and TNet. So this table basically shows commands that you can use to collect data in the network. So example here is show version. So displays uptime version information for devices, software, and hardware. Show IP internet brief. Show IPv6 internet brief. We have already done this or lectured this before. Show interfaces, IP route, IPv6. So neighbors, running config, VLAN, tech support. So basically these are the commands that we will use CCNA or in networking. So I think that is it. So I'm done with network documentation. That is all. Thank you.
Hi everyone, I am Marilue Umunlay and this is the continuation of our report, the troubleshooting process. General troubleshooting procedures. Troubleshooting can be time-consuming. Because networks differ, problems differ, and troubleshooting experience varies. However, experienced administrators know that using a structured troubleshooting method will shorten overall troubleshooting time. Therefore, the troubleshooting process should be guided by structured methods. This requires well-defined and documented troubleshooting procedures to minimize wasted time associated with erratic hit and miss troubleshooting. There are several troubleshooting processes that can be used to solve a problem. The figure below displays the logic flowchart of a simple three-stage troubleshooting process. However, a more detailed process may be helpful to solve a network problem. So, stage 1, gather symptoms, then isolate the problem, then implement corrective action. Then, it will be divided into action. If the problem is fixed, document solution and save changes. If it did not fix the problem or it created another problem, undo corrective action and start again. 7-step troubleshooting process. The figure displays a more detailed 7-step troubleshooting process. Notice how some steps interconnect. This is because some technicians may be able to jump between steps based on their level of experience. So, these are define problems, gather information, analyze information, eliminate possible causes, propose hypotheses, test hypotheses, and solve the problem and document solution. So, let's define it individually. Define the problem. The goal of this stage is to verify that there is a problem, then properly define what the problem is. Problems are identified by a symptom. Example, the network is slow or has stopped working. So network symptoms may appear in many different forms, including alerts from the network management system, console messages, and user complaints. While gathering symptoms, it is important to ask questions and investigate the issue in order to localize the problem to a smaller range of possibility. For example, is the problem restricted to a single device, a group of devices, or an entire subnet or network of devices? Next is gather information. In this step, targets to be investigated must be identified. Access to the target devices must be obtained and information gathered. During this step, the technician may gather and document more symptoms depending on the characteristics that are identified. If the problem is outside the boundary of the organization's control, example, loss of internet connectivity outside of the autonomous system, then we should contact an administrator for the external system before gathering additional network symptoms. Next is analyze information. Possible causes must be identified. The gathered information is interpreted and analyzed using network documentation, network baselines, searching organizational knowledge bases, searching the internet, and talking with other technicians. Then, eliminate possible causes. If multiple causes are identified, then the list must be reduced by progressively eliminating possible causes to eventually identify the most probable cause, and troubleshooting experience is extremely valuable to quickly eliminate causes and identify the most probable cause. Next is propose hypothesis. When the most probable cause has been identified, a solution must be formulated. At this stage, troubleshooting experience is very valuable when proposing a plan. Test hypothesis. Before testing the solution, it is important to assess the impact and the urgency of the problem. For instance, could the solution have an adverse effect on other systems or processes? The severity of the problem should be weighed against the impact of the solution. If the solution fails, the attempted solution is documented and the changes are removed. The technician must now go back to the gathering information step and isolate the issue. Last is solve the problem. When the problem is solved, inform the users and anyone involved in the troubleshooting process that the problem has been resolved. Other IT team members should be informed of the solution. Appropriate documentation of the cause and the fix will assist other support technicians in preventing and solving similar problems in the future. Question end user. Many networks problems are initially reported by an end user. However, the information provided is often vague or misleading. For example, a user often reports problems such as the network is down, I cannot access my email, or my computer is slow. In most cases, additional information is required to fully understand a problem. This usually involves interacting with the affected user to discover the who, what, and when of the problem. So the following recommendations should be employed when communicating with users. Speak at a technical level they can understand and avoid using complex terminology. Always listen or read carefully what the user is saying. Taking notes can be helpful when documenting a complex problem. And always be considerate and emphasize with user while letting them know you will help them solve their problem. User reporting a problem may be under stress and anxious to resolve the problem as quickly as possible. When interviewing the user, guide the conversation and use effective questions, techniques to quickly ascertain the problem. So the table provides some questioning guidelines and sample open-ended end user questions. So this is the guidelines and example open-ended end user questions. So as pertinent questions. So example, what does not work? What exactly is the problem? What are you trying to accomplish? Determine the scope of the problem. Who does the issue affect? Is it just you or others? What device is this happening on? Determine when the problem occurred or occurs. When exactly does the problem occur? When was the problem first noticed? Were there are any error messages displayed? Determine if the problem is constant or intermittent. Can you reproduce the problem? Can you send me screenshots on video of the problem? Determine if anything has changed. What has time since the last time it changed? Use questions to eliminate or discover possible problems. What works? What does not work? Gather information. To gather symptoms from suspected networking device, use Cisco IOS commands and other tools such as packet captures and device logs. The table describes common Cisco IOS commands used to gather the symptoms of a network problem. So, this is it. Command, ping, curly braces, host IP address, sends an echo request packet to an address, then waits for a reply. It is also the host or IP address variable is the IP alias or IP address of the target system. Trace out destination. Identifies the path a packet takes through the networks. It is also the destination variable is the host name or IP address of the target system. Telnet curly braces host IP address. Connect to an IP address using the Telnet application. Use SSH whenever possible instead of Telnet. SSH user IP ID IP address connects to an IP address using SSH. SSH is more secure than Telnet. Show IP interface brief. Display a summary status of interface on a device. Show IPv6 interface brief. Useful for quickly identifying IP address on all interfaces. Show IP route. Show IPv6 route. Display the current IPv4 and IPv6 routing tables, which contains the routes to all known network devices. Show protocols. Display the configured protocols and shows the global interface specific status of an configure layer 3 protocols. Debug. Display a list of options for enabling or disabling debugging events. Note: although the debug command is an important tool for gathering symptoms, it generates a large amount of console messages traffic, and the performance of a network device can be noticeably affected. If the debug must be performed during normal work hours, warn network users that troubleshooting effort is underway and the network performance may be affected. Remember to disable debugging when you are done. Troubleshooting with layer models. The OSI and TCP or IP models can be applied to isolate network problems when troubleshooting. The figure shows some common devices and the IOS layers that must be examined during the troubleshooting process for the device. Hub is found in layer 1, which is the physical layer. Standard switch in data link layer. Router and multi-layer switch in network and transport layer, while end systems are in session, presentation, and application layer. Notice that routers and multi-layer switches are shown at layer 4, the transport layer. Although the routers and multi-layer switches usually makes forwarding decisions at layer 3, ACLs on these devices can be used to make filtering decision using layer 4 information. Structured troubleshooting method. There are several structured troubleshooting approaches that can be used. Which one to use will depend on the situation. Each approach has its advantages and disadvantages. This topic describes methods and provides guidelines for choosing the best methods for a specific situation. So these are bottom up, top down, divide and conquer, follow the path, substitution, comparison, and educated guess. Bottom up. In bottom up troubleshooting, you start with the physical layer and the physical components of the network as shown in the figure, and move after the layers of OSI model until the cause of the problem is identified. Bottom-up troubleshooting is a good approach to use when the problem is suspected to be a physical one. Most networking problems reside at the lower levels, so implementing the bottom-up approach is often effective. The disadvantage with the bottom-up troubleshooting approach is it requires that you check every device and interface on the network until the possible cause of the problem is found. Remember that each conclusion and possibility must be documented so that there can be a lot of paperwork associated with this approach. A further challenge is to determine which devices to start examining first. Next is top-down. As shown in the figure, top-down troubleshooting starts with the end-user application and moves down through the layers of OSI model until the cause of the problem has been identified. End-user application of an end system are tested before tackling the more specific network species. Use this approach for simpler problems or when you think the problem is with a piece of software. The disadvantage with the top-down approach is it requires checking every network application until the possible cause of the problem is found. Each conclusion and possibility must be documented. The challenge is to determine which application to start examining first. Divide and conquer. The figure shows the divide and conquer approach to troubleshooting a network problem. The network administrator selects a layer and tests in both directions from the layer. In divide and conquer troubleshooting, you start by collecting the user experiences of the problem. document the symptoms, and then, using the information, make an informed guess as to which OSI layer to start your investigation. When a layer is verified to be functioning properly, it can be assumed that the layers below it are functioning. The administrator can work up the iOS layers. If an OSI layer is not functioning properly, the administrator can work down the OSI layer model. For example, if users cannot access the web server but they can ping the server, then the problem is above layer 3. If pinging the server is unsuccessful, then the problem is likely at lower OSI layer. This is one of the most basic troubleshooting techniques. The approach first discovered the traffic path all the way from the source to destination. The scope of troubleshooting is reduced to just the link and devices that are in forward path. The objective is to eliminate the links and the devices that are irrelevant to the troubleshooting task at hand. This approach usually complements one of the other approaches. Substitution. This approach is also called the swap the component because you physically swap the problematic device with known working one. If the problem is fixed, then the problem is with the removed device. If the problem remains, then the cause may be elsewhere. If the problem lies with multiple devices, it may not be possible to correctly isolate the problem. Comparison. This approach is also called the spot the differences approach, and attempts to resolve the problem by changing the non-operational elements to be consistent with the working ones. You compare configuration, software version, hardware or other device properties, links or processes between working and non-working situation, and spot significant differences between them. The weakness of this method is that it might lead to a working solution without clearly revealing the root cause of the problem. And last, the educated guess. This approach is also called the shoot from the hip troubleshooting approach. This is less structured troubleshooting method that uses an educated guess based on the symptoms of the problem. Success of this method varies based on your troubleshooting experience and ability. Seasoned technicians are more successful because they rely on their extensive knowledge and experience to decisively isolate and solve network issues. With less experienced network administrator, this troubleshooting method may too random to be effective. Guidelines for selecting a troubleshooting method. So the figure illustrates which method could be used when a certain type of problem is discovered. Define the problem. So determine the type of problem, analyze the symptoms, and apply previous experience. Determine type of the problem. If it is software-oriented, use top-down method. If it is hardware or cable-oriented or complex, use bottom-up method. In apply previous experiences, if it is new problem, apply bottom-up method, and if is experienced before, apply divide and conquer method. For instance, software problems are often solved using a top-down approach, while hardware-based problems are solved using the bottom-up approach. New problems may be solved by an experienced technician using the divide and conquer method. Otherwise, the bottom-up approach may be used. Troubleshooting is a skill that is developed by doing it. Every network problem you identify and solve gets added to your skill set. Thank you.
Hello guys, we're gonna tackle about troubleshooting tools. First, we're gonna tackle is what software we're gonna use for troubleshooting. So a wide variety of software and hardware tools are available to make troubleshooting easier. These tools may be used to gather and analyze symptoms of network problems. They often provide monitoring and reporting functions that can be used to establish the network baseline. There are common software troubleshooting tools. First is the network management system tools. The network management system tools include device level monitoring, configuration, fault management tools. These tools can be used to investigate and correct network problems. Network monitoring software graphically displays a physical view of network devices, allowing network managers to monitor remote devices continuously and automatically. Device management software provides dynamic device status, statistics, and configuration information for key network devices. The second is knowledge bases. Knowledge bases, online network device vendor knowledge bases have become indispensable sources of information. When vendor-based knowledge bases are combined with internet search engines, a network administrator has access to vast pool of experience based on information. The third tools is baselining tools. Many tools for automating the network documentation and baselining process are available. Baseline tools help with common documentation. For example, they can draw network diagrams, help to keep software and hardware documentation up to date, and help to cost effectively measure baseline network bandwidth use. The next we're gonna talk about is the hardware troubleshooting tools. No, I mean protocol analyzer. The protocol analyzer investigate packet content while flowing through a network. As you can see on this picture, you can see the time, source, destination, protocol, and info, the transaction ID, and you can see also the packet content while flowing through the network. The information displayed by a protocol analyzer includes the physical layer, bit data, data link layer information, protocols, and description for each frame. Most protocol analyzer can filter traffic that meets certain criteria so that all traffic to and from a device can be captured. So as you can see on the picture, you can see the frame 1, how many bytes on where, then on the Ethernet and the Internet protocol. So the next is hardware troubleshooting tools. There are multiple types of hardware troubleshooting tools. First is the digital multimeters. The digital multimeters, they test instruments that are used to directly measure electrical values like voltage, current, and resistance. In network troubleshooting, most tests that would need a multimeter involve checking the power supply voltage level and verifying that the network devices are receiving power. Because there's a disadvantage if you didn't check the voltage level, maybe it will be overpower, or what to call this, it's not stable supply voltage. Then the second is the cable testers. Cable testers are specialist handheld devices designed for testing the various type of data communication cabling. The figure displays the flock link runner at network auto tester. The cable tester can be used to detect broken wires, crossover wiring, shorted connections, and improperly paired connections. These devices can be inexpensive continuity testers, moderately priced data cable tester, or expensive time domain reflectometers. The cable tester used for testing some LAN cable. If your LAN is broken wires, then you will use cable tester to see if it is working or not. Okay. The third is cable analyzers. Cable analyzers are multifunctional handheld devices that are used to test and certified copper and fiber cables for different services and standards. The more sophisticated tools include advanced troubleshooting diagnostics that measure the distance to a performance defects such as near-end crosstalk or return loss, identify corrective actions, and graphically display crosstalk and impedance behavior. Cable analyzers also typically include PC-based software. After field data is collected, the data from the handheld device can be uploaded so that the network administrator can create up-to-date reports. The fourth one is portable network analyzer. Portable devices are used for troubleshooting switch networks and VLANs. By plugging the network analyzer in anywhere on the network, a network engineer can see the switch port to which the device is connected and the average and peak utilization. The analyzer can also discover VLAN configuration, identify top network talkers, include host generating and the most traffic. Analyze the network traffic, view interface details. The fifth is Cisco Prime NAM. The Cisco Prime Network Analysis Module portfolio shown in the figure includes hardware and software for performance analysis in switching and routing environments. It includes an embedded browser-based interface that generates reports on the traffic that consumes critical network resources. So these are the Cisco Prime NAM devices. This is the Cisco Nexus 7000, Cisco Catalyst 65XX, Cisco Prime NAM 2300 series appliance, Cisco Prime NAM Virtual NAM, Cisco Prime NAM for Cisco Nexus 1110, then the Cisco Prime NAM for ISR G2 SRE. So there is too many Cisco Prime NAM, not only this. Next is Syslog server as a troubleshooting tool. Syslog is a simple protocol used by an IP device known as Syslog client. To send text-based log messages to another IP device, the Syslog server system is currently defined RFC 5424. So there will be an event message on the Syslog server. The first is console. Console logging is on by default. Messages log to the console and can be viewed when modifying or testing router or switch use terminal emulation software while connected to the console port of the network device. The second one is terminal lights. If you enable execute sessions can be configured to receive log message under any terminal lights. Like console logging, this type of logging is not stored by the network device and therefore is only viable to the user on that line. The third one is buffered logging. Buffered logging is a little more useful as troubleshooter because log message are stored in memory for a time. However, log message are queued when the device is rebooted. So buffered logging, the message can be stored in any time, but the system will be rebooted. It will be cleared. Okay. The fourth one is SNML traps. Certain thresholds can be pre-configured on router and other devices. Router events such as exceeding a threshold can be processed by the router and forwarded as SNMP traps to an external SNMP network management station. SNMP traps are viable security logging facility but require the configuration and maintenance of an SNMP system. Syslog. Cisco router and switches can be configured to forward log message to an external syslog services. These servers can reside on any number of servers or workstations, including Microsoft Windows, Linux-based system. Syslog is the most popular message logging facility because it provides long-term log storage capabilities and central location for all router messages. Cisco iOS log messages fall into one of 8 levels as shown in the table. The 0 level is the emergency, the level 1 alerts, level 2 critical, level 3 errors, level 4 warning, level 5 notification, level 6 informational, level 7 is the debugging. The alert level, which is immediate action is needed, like something in the Microsoft, like some virus, it will pop up in the system security that you need to do an action, whether quarantine or remove that. Then the lower level number, the higher the severity level. By default, all messages from level 0 to 7 are logged to the console, while the ability to view logs on central syslog server is helpful in troubleshooting. Sifting through a large amount of data can be an overtask the login trap level. The syslog server based on the severity, the level is the name or number of the severity level, only message equal to this is the what command when you send to the server log at that 209.165.200.255. You will type logging space host, then the IP, logging track notification, then logging on. And that's all. Thank you.
Good afternoon. Ang atong discuss karon is symptoms and causes of network problems. So, ang first is physical layer troubleshooting. Ang mga symptoms and causes sa physical layer. So, mo siya naka-indicate mo niyang figure. So, ang symptoms niya, performance lower than baseline, loss of connectivity, network bottlenecks or congestion, high CPU utilization rates, console error messages, and causes niya. Power-related, hardware faults, cabling faults, attenuation, noise, interface configuration, errors, exceeding design limits, and CPU overload. So, muna siya naka-specify ang description niya sa kada symptoms. So, pag performance lower than baseline, meaning, kasabot ana nga, symptom na siya nga may problem sa muang physical layer. Requires previous baseline for comparison. The most common reasons for slow or poor performance include overloaded or underpowered servers, unsuitable switch or router configurations, traffic congestion and a low capacity link, and chronic frame loss of connectivity due to a failed or disconnected cable can be verified using a simple pin test. Network bottlenecks or congestion, mausa sila ang traffic, dapat ito inatuyo sa tan para maginhawag yapon ato ang network. Then high CPU utilization rates, meaning way pahuway ato ang device, router, switch, server, unsa ba dia mao nang overload siya. CPU overloading can cause a device to shut down or fail by itself. Then console error messages, pag mugawas lagi na mga error messages, meaning natay problem sa tuang physical layer. Console messages will be logged to a central syslog server. Physical layer problem. So, mo ni siya ang causes. Ano natay? Physical layer problems. Then, power related. This is the most fundamental reason for network failure. Nearby units have also power down. Suspect a power failure at the main power supply. Hardware faults. Faulty network interface cards can be the cause of network transmissions. Errors due to late collisions, short frames, and jobber. Cabling faults. Many problems can be corrected by simply resetting cables that have become partially disconnected. So, reset lang balik atong mga cables para ma-okay sila balik. Then, attenuation can be caused if a cable length exceeds the design limit for the media, or when there is a poor connection resulting from a loose cable or dirty or oxidized contact. If attenuation is severe, then the receiving device cannot always successfully distinguish one bit the data stream from another bit. noise, ano siya, sabotable na siya. Then, interface configuration errors, dapat configure na itong sakto atong mga interface para wala problema, di walang connectivity, exceeding design limits, and CPU overload. So, similar siya sa CPU ay sa high CPU utilization. So, dapat magpaway na to ang CPU, tapos dapat naka-reset sa sige, dapat naka-refresh aron dili mag-overload and dili magka-problema sa to ang physical layer network. The next is data link layer. So, data link layer, ang mga symptoms o yung no functionality or connectivity at network layer above, network operating below, baseline performance levels, excessive broadcast, console messages, gawas ng messages. Then, ang process nga nung natay, data link layer, network problems, encapsulation errors, address mapping errors, framing errors, STP failure loop. No functionality, some problems can stop the exchange of frames across a link, while others only cause network performance to degrade. Network is operating below baseline performance levels. There are two distinct types. Then an extended or continuous ping can help reveal if frames are being dropped. Excessive broadcast. Operating systems use broadcast and multicast extensively to discover network services and other hosts. Generally, excessive broadcasts are the result of a poorly programmed or configured application. Console messages, a router recognizes that there is a problem and sends alert messages to the console. So, pag nanagay magawas sa console messages, meaning nanay sintomas na nga natay problema sa tuang data link layer. So, ma-causes nga nung natay problem sa itong data link. Encapsulation errors. Yung encapsulation error occurs because the bits placed in the field by the sender are not what the receiver expects to see. So, dili man dyan na siya always compatible ang bits nga madawat na to gikan sa sender. So, meaning, magka-problema dyan sa ato ang data link layer. Then, address mapping errors in topologies such as multi-point Voltage Ethernet is essential that an appropriate layer to destination address given to the frame. This ensures its arrival at the correct destination. Dapat mag-mapping ta sa atong topology, dapat sakto yun ay para ulit problema. Then framing errors, frames usually work in groups of 8-bit bytes. It's not end in 8-bit boundary. So dapat naka-end dito sa 8 daw. STP failures or loops. So next is network problem. Ang symptoms and causes sa network layer, network problem. So muna siya ang figure. Pag nanagay network failure o suboptimal performance, meaning symptoms na siya nga gakahinay ato ang network layer. So mo niya ang causes niya. General network issues, connectivity issues, routing table, neighbor issues, and topology database. So muna ang description sa each symptom. Pag nalagay network failure, meaning the network is nearly or completely non-functional. Let me say function affecting all users and applications on the network. So dapat kina-check natin siya daily para wala problema. These failures are usually noticed quickly by users and network administrators and are obviously critical to the productivity of a company. Sabot ana pag fail ang network, meaning wala tawag nga mabuhat. So lisod kayo, apektuhan ka o ang imong trabaho labaw na ang kumpanya nga imong gitabahoan. Suboptimal performance, network optimization problems usually involve a subset of users, applications, destinations, or a type of traffic. So, muna siya ang process, network layer problems, general network issues often change. Topologies such as downlink may have effects on the other areas of network that might not be obvious at the time. Connectivity issues, check for equipment and connectivity problems, including power problems such as outage and environmental problems. So, dapat kablota kung ang sima problema sa tuwang palibot, kung nga ba mag-blackout ba niya, or unsa ba kay maka problema siya sa tuang connectivity issues, maka-delay siya sa trabaho. In routing table, check the routing table for anything unexpected such as missing routes or unexpected routes. Use debug commands. Meaning, importante kayong mag-debug ka kanunay para ma-reset o ma-refresh ang atuang mga commands o ibang palya. The neighbor issues. Routing protocol establishes an agency with a neighbor. Check to see if there are any problems with the routers forming neighbor adjacencies. Topology database. Dapat nakaset atong data topology para wala problema o nakamap siya eksakto. Routing protocols will database check there of anything unexpected such as missing entries or unexpected entries. So, mo lagi dapat naka-double check na to ato ang table o sakto atong pagbuhat sa atong topology date. Next is transport layer troubleshooting sa ACLs. Network problems can arise from transport layer problems on the router, particularly at the edge of the network, where traffic is examined and modified. For instance, both access control lists, ACLs, and the network address translation, which is not operate at the network layer and may involve operations at the transport layer as shown in the figure. Operate at the network layer and may involve operations translated as shown in the figure. So, ang symptoms ng transport layer problems sa atong ACLs is connectivity issues and access issues. Process niya, ACL configurations and NAT configurations. So, muna siya ang most common ACL misconfigurations, selection or traffic flow, order of ACL entries, visit deny any, and address and IPv4 wildcard mask, selection of transport layer protocol, source and destination ports, use of the established keyword, and uncommon protocol. So, muna siya ang young description. So, muna siya ang common misconfiguration sa atong ACL. Selection of traffic flow. Traffic is defined by both the router interface through which the traffic is traveling and the direction in which this traffic is traveling. So, naka-specify gid siya kung asa kung ng router interface this traffic is traveling. Specify gid niya. Then, an ACL must be applied to the correct interface and the correct traffic direction must be selected to function properly. Order of access control entries. The entries in an ACL should be from specific to general. Then, inbound traffic is processed by the inbound ACL before being processed by outside to inside NAT. Outbound traffic is processed by the outbound ACL after being processed by inside to outside NAT. Implicit deny any when high security is not required on the ACL. This implicit access control element can be the cause of an ACL misconfiguration. Then addresses and IPv4 wildcard masks. Complex IPv4 wildcard masks provide significant improvements in efficiency but are more subject to configuration errors. An example of wildcard mask is using IPv4 address 10.0.32.0 and wildcard mask 0.0.32.15 to select the first 15 host addresses in either the 10.0.0.0 network or the 10.0.32.0 network. Pretty good. Selection of transport layer protocol. When we're configuring ACLs, it is important that only the correct transport layer protocols be specified. Specific na dapat sa tuang transport layer protocols kay para wala problema sa tuang pag-configure sa ACL. Source and destination ports. Properly controlling the traffic between two hosts requires symmetric access control elements for inbound and outbound ACLs. Address and port information for traffic generated by a replying host is the mirror image of address. And port information for traffic generated by the initiating host. Use of the established keyword. The established keyword increases the security provided by an ACL. However, if the keyword is applied incorrectly, unexpected error may occur. So, samawa na dapat ang password na to is strong. And mga different characters, but dapat always na abot upper may dapat itong password ka nang dili na ito malimtan kay kung malimtan na to siya, ma-type na to dili insakto, meaning may mga results nga expected o magka-problema siya. Then, uncommon protocols. Misconfigured ACLs often cause problems for protocols other than TCP and UDP. Uncommon protocols that are gaining popularity are VPN and encryption protocols. Mo gini kung kang panahon na kay gusto sila kusog nga, sige na kayo. Then, the log keyword is a useful command for viewing ACL operation on ACL entries. This keyword instructs the router to place an entry in the system log whenever that entry condition is matched. The log event includes details of the packet that match the ACL element. The log keyword is especially useful for troubleshooting and provides information on intrusion attempts being blocked by the ACL. The next is transport layer troubleshooting NAT for IPv4. So, muna siya ang common interoperability areas. OTP, BOOTP, and DHCP, DNS, and WINS, SNMP, tunneling, and encryption protocol. So, na lang description. BOOTP and DHCP. Both protocols are managed automatic assignment of IPv4 to clients. DNS, because a router running dynamic NAT is exchanging the relationship between inside and outside addresses regularly as stable entries expire and are recreated. A DNS server outside the NAT router does not have an accurate representation of the network inside the router. So, moto, configuring the IPv4 helper feature can help solve this problem. SNMP, like DNS packets, NAT is unable to alter the address information stored in the data of payload of the packet. Because of this, an SNMP management station on one side of a NAT router may not be able to contact SNMP agents on the other side of the router. And tunneling and encryption protocols. Na siya, encryption and tunneling protocols often require the traffic be source. Then. Auto-encapsulation protocols used by VPN implementations and cannot be processed by NAT. Lagi po yung uban nga magamit ang VPN para makasunod sila sa kusog ng network, sa signal, then sa hindi siya ma-process, hindi siya pwede ma-process sa NAT. Then lastly is ang application layer. Most of the application layer protocols provide user services. Application layer protocols are typically used for network management, file transfer, distributed file services, terminal emulation, and email. New user services are often added, such as VPNs and VoLP. This shows the most widely known and implemented TCP/IP application layer protocols. TCP, kami siya, application sa transport, kami ang internet, routing protocols, IPSMP, sa network, ARP, ND, o yung sa physical, there, wala naka-specified. So, muna siya ang mga applications na ginagamit ato sa tuwang networks, different layers, I mean. So, sa SSH or Telnet, it enables users to establish terminal session connections with remote hosts. HTTP, muna yung pinaka-common kay, or mag-search sa internet, na magawas nga HTTP sa taas sa to ang link. Supports the exchanging of text, graphic, images, sound, video, and other multimedia files on the web. FTP performs interactive file transfers between hosts. TFTP performs basic interactive file transfers between hosts and networking devices. SMTP supports basic message delivery services, connects to mail and servers, and downloads email. SNMP collects management information from network devices. DNS maps IP addresses to the names of said network devices. So, nakaagi na po dyan Monitig, naka-automatic nga mag-map sa IP addresses sa tuwang network devices. Then, NFS, Network File System. It enables computers to mount drives on remote hosts and operate them as if they were local drives. Originally developed by Sun Microsystems, it combines with two other application layer protocols, external data representation XDR, and remote procedure called allow transparent access to remote resources. So, buwad din siya application kaning NFS. So, balikutin niya siya, then, but gamit kayo siya. So, maka-contact avoid mga problems. Then, types of symptoms and causes depend upon the actual application itself. So, dili pa magawas ang mga simptomas niya na nasa problema or ang mga causes na nasa problema. But pag pag ma-apply na, meaning di na magawas ang mga simptomas o ang mga causes sa problems. Application layer problems to prevent services from being provided to application programs. A problem at the application layer can result in an unreachable or unusable resources when the physical, data link, network, and transport layers are functional. It is possible to have full network connectivity, but the application simply cannot provide data. Another type of problem that the application layer occurs when the physical, data link, network, and transport layers are functional, but the data transfer and request for network services from a single network service or application do not meet the normal expectations of the user. So, kami application na siya. Magka-problema niya siya kung katuwang sige yung sa ito pagtrabaho. So, kapag may isa ka mali sa itong trabaho, meaning mag-connect siya sa data link, sa physical layer, network layers, transport layers. So, puti yun siya dapat kanang specific yun itong trabaho o natay plano good. Then, a problem at the application layer may cause users to complain that the network or an application that they are working with is sluggish or slower than the usual when transferring data or requesting network services. So, all in all, dapat ibalutang anong nanay si mga sintomas, anong hinay na ang performance level sa to ang mga network. Dapat kabalutaan na og nganong siga anong inungdan anong kainay ang performance sila, dapat kabalutaan na og usa ang solution. Dapat kabalutaan sa solution para mapadayon ng productive ang trabaho og nakay makitabang sa imong sarili para ma-proud ka og nabaw na sa kumpanyang imong trabaho. So, thank you for listening and God bless.
Hello guys, for today's video is we're gonna tackle network troubleshooting. First topic is components of troubleshooting end-to-end connectivity. So sa diri nga makita na to nga chart, na share chart, then ato siyang i-troubleshoot if nagay error, and may mga steps para ang administrator iyang ma-check kung unsay problem. Ang first is i-check na to ang physical connectivity sa point where network communication stops, internal cables or hardware. Then second is i-check na to yung ang duplex. Dahil ang third, check na to ang data link and network layer addressing in the local network. Include ang IPv4 ERP tables, IPv6 neighbor tables, MAC address tables, and VLAN assignments. Then ikapat, i-verify na to ang default gateway if it is sakto ba or dili. Then ang kalima, i-ensure na to na ang devices kay gidetermine niya ang correct path from the source to destination. Then ikaw no, verify na to ang transport layer if function ba siya properly using pwede mo magamit og telnet to test transport layer connection from the command line. Then ang ika-7, verify na to ang nga walay ACLS block traffic. Then ika-8, i-ensure na to nga ang DNS settings kay sakto, then the DNS server that is accessible. So mo to siya mga steps para makita na to ang components of troubleshooting end-to-end connectivity. Ang sunod, end-to-end connectivity problem initiate troubleshooting. So sa diri magamit ta og ping o trace route sa makita na to diri sa picture. Magamit og ping and trace route diri sa PC1. So first, ang ping muna siya timailhan na kung nabay connection ang example, may connection ng PC1 to R1 i-ping nato siya kung ilan, i-type lang nato sa terminal nga ping tapos IP address. Kung na mo reply nga upat ka buok nga connection, which is nga success or correct ang connection nila. Dayon sunod is trace route. Ang trace route, which means same lang siya o sa ping, pero ang makabutang is makita na to ang MS nila kung ang trace route success ba lang connection. Dili ang trace route gikan sa pinakauna gikan sa PC1 paingon sa router, tapos mabalik siya, i-check niya tanan kung success ba. Dayon sunod is ping and trace route. Then sa ping and trace route, same lang yapon sa ping, pero atong gamiton which is the MAC address. Ping tapos MAC address, i-check niya na makabutang sending 5 tapos na success rate is 100%. Then sa trace route and MAC address, na makabutang nga mga MAC address na sa trace route kung unsa tong MAC address iyong ginaping. Dayon nadayon mga steps na sa pag-troubleshoot. Ang first kay mag-verify sa physical layer. Second, check for the duplex mismatches. So mo to siya tong gipang-ingon og na. So first is ato ni tackle ang step 1. Ang step 1, tanan devices, especially ang computer system, at a minimum, this device consists of CPU, RAM, and storage space, allowing the device to boot and run the operating system interface. It allows for the reception and transmission of network traffic. When network administrator iyang determine na may problem exists on a given device, and that problem might be hardware related, it is worthwhile to verify the operation of these generic components. And the mostly common used Cisco iOS commands for the purpose are show processor CPU, show memory, and show interface. Muna siya mga command nga gamito nato para makita tong mga atong na problem. Dayon kung mag-troubleshoot ta, first is gamito nato ang show interfaces. Dayon gigabit Ethernet 00. Diri nato makita nato ang tanan, ang input queue, output queue, dayon mga packets, broadcast, input errors, output errors. Diri nato makita kung nabay error or wala. Dayon na po yung mga explanation of the highlighted output. First is input queue drops. Kaya input queue drops, ginasignify niya ang some point more traffic was delivered to the router than it could process. This does not necessarily indicate a problem that could be normal traffic during peak periods. However, it could be an indication that the CPU cannot process packets in timer. So if this number is consistently high, it is worth trying to spot at which moments these counters are increasing, how this relate to CPU usage. Second is ang output. Kaning output queue drops, ga-indicate siya mga packets nga ga-drop due to congestion on the interface. Then sa output pod, seeing output drops is normal for any point where the aggregate input traffic is higher than the output traffic. Then during pod sa peak traffic periods, packet are dropped if ang traffic ga delivered to the interface faster than it can be sent out. However, iya pong gina-consider ang normal behavior nga leads to packet drops in queuing delay. So, applications that are sensitive to those such as VoIP might suffer from performance issues. Consistently seeing output queue drops can be indicator that you need to implement na kailangan na to mag-implement og advanced nga queuing mechanism or modify nga QoS. Sunod kay input errors. Ang input errors, gina-indicates niya ang errors na ma-experience during the reception frame or CRC errors. High numbers of CRC errors could indicate cabling problems and interface problems or in an internet-based network, duplex mismatches. Then, output errors. Output errors indicate errors such as kanang collisions during transmission of a frame. Pwede po nga most internet-based network today kay naka full duplex naman tatanan or half duplex. In full duplex transmission, operation collisions cannot occur. Therefore, collisions, especially late collision, often indicate duplex mismatches. So, step 2, i-check na to ang duplex mismatches. So, another common cause na the interface error is mismatch duplex mode between two ends of the Ethernet link. In many Ethernet-based networks, point-to-point connection are not norm. Use of hubs that associated half duplex affairs is become less common. This means nga ang most Ethernet links karon ga-operate na sila full duplex, and while collision were normal for an Ethernet link, collision today often indicate that duplex negotiation has failed or the link is not operating in the correct duplex. However, if a duplex negotiations fails for some reason, na siya necessary nga maset siya speed and duplex manually on both ends. Maset siya nga manually on both ends if mag-fail. Typically, this would be setting duplex mode to full duplex on both ends of the connection. If it does not work, if dili ga work ang full duplex, mag-change ka og half duplex. Dayon, mo ni ang guidelines nga duplex configuration. Include auto negotiation of speed and duplex is recommended. Second, if auto negotiation fails, manually set speed duplex on interconnecting ends. And katulo, point-to-point Ethernet link should always run in full duplex mode. Half duplex is uncommon, typically encountered only when legacy hubs are used. Troubleshooting example. So, kani nga picture, I am experiencing significant performance issues when communicating with SRv2. Then, ang administrator, nag-notice siya sa console message on switch S2 nga ang duplex nakabutang mismatch na discovered diri sa Fast Ethernet 020 diri sa S1. Dayon, next niya gibuhat nga gishow niyang interface sa Fast Ethernet 020 kung unsay kuan niya nga duplex, naka full ba siya, naka-half o nakabutang nga indicate full duplex. Dayon, ang network administrator yung gi-examine ang other side connection support kung unsay status dito sa duplex. Pero ang dito sa S2 nga switch ang nakabutang half duplex para nga masakto ang para dili ma-mismatch, kinahanglan nga ang S1 ug S2 same sila nga full duplex. Dayon, step 3 kay i-verify nato ang addressing sa local network. Kung mag-troubleshooting ta sa end-to-end connectivity, it is useful to verify the mappings between destination IP address and layer 2 internet addresses on individual segments. In IPv4, this functionality is provided by ARP. In IPv6, the ARP functionality is replaced by the neighbor discovery process and ICMPv6. The neighbor table caches IPv6 addresses the resolved Ethernet physical MAC address. Para ma-verify nato ang layer 2 ug layer 3 addressing, naay upat kabok na pamagi. first is the Windows IPv4 ARP table. So para makita na tong ARP nga table, i-type na to ang ARP ARP-A. Dayon makita nimo dito tanan nga ang internet address, makita nimo physical address, unsa po siya nga type, dynamic ba siya or static. Ang ikaduha kay ang Windows IPv6 neighbor table. Para makuha na to ng command, i-type na to nga netsh interface IPv6 show neighbor. Kung makita nato diri ang internet address, makita po nato diri ang physical o type niya, kung reachable, permanent or stale. Ay katulo ang iOS IPv6 neighbor table. Ato ra nang i-type nga show IPv6 neighbor kung kinsa toy duol siya, kinsa toy ang neighbor, kinsa toy mga neighbors kani nga address. Dayon na sunod kay switch MAC address table. Ato ra gyapon i-show nga, ato ra type sa command nga sa terminal nga show MAC address table. Makita nato diri ang VLAN, unsa siya nga VLAN, asa siya VLAN sa kani VLAN tanan. Kay MAC address niya, unsa iyang type, static ba, dynamic, then iyang port, CPU. Dahil makita. Dahil sunod nato kay troubleshoot VLAN assignment. Sa troubleshoot VLAN assignment, naay mga tulo nga process. Ang tulo nga process, ARP gyapon, which is nga i-type gyapon nimo ARP-A. Makita nimo dito gyapon tanan ang internet address, physical address o static. Ang sunod, check the switch MAC table. Show ang command, show MAC address table. Makita gyapon nimo dito VLAN 10, MAC address type, dayon ports, dayon correct the VLAN assignment. I-check niyo, pag-check nimo, i-interface nimo, dayon mag-switch port ka, dayon switch for access VLAN kung asa gid siya nga, kung asa gid naka-assignment. Example, gitagaan ka kanang topology. Example, kani nga MAC address, ibutang ni siya sa VLAN 20. I-port nimo nga switch port mode interface, dayon switch port access VLAN 20, then exit, then show MAC address table. Makita din nimo nga asa naka-assign ba to nga proper VLAN or wala. Dahil ikaupat, step 4, i-verify na itong default gateway. Sa diri nga table, my default gateway is R1. Ano siya? Sa PC1. Then, ang default gateway sa R1, R2. Dayon, para ma-check na to ang command output sa R1 and PC1, ato siya show IP route and include gateway 000. Then the gateway of last resort is 192.168.1.2 to network 00. Dayon ang PC routing table mo siya ang route print. Dayon makita nimo ang gateway nimo, dayon ang interface. Example, mo ni atong interface. Makita dito na mo ni ang gateway, sakto ang gateway. Same lang process kung i-check nimo sa router 1, show running config ka, pangitaw nimo ang gateway dito, i-double check nimo kung sakto ba sa R2 o dili. Dayon sunod is troubleshooting gateway. Same lang sa IPv4 kung ang pamaagi sa IPv6. Pero natay lima ka mga explanation para makuha na ito, matroubleshoot na itong IP default gateway issue. Ang first, ang R1 routing table. I-show na itong IPv6 route. Dayon na siya makabutang diri nga gateway, example via, then the MAC address. Then i-double check nimo kung kani nga MAC address sakto ba ni dito sa router 1. Dayon sunod IP config. Sa IP config, diyan nimo makita nga mag-show siya IP address then gateway. Then double check naman siya kung sakto siya ang routing table. Kasunod, check R1 interface settings. Then kuan mo siya show IPv6 interface gigabit. Dayon makita nimo kung unsay MAC address ug subnet niya. Then ang correct sunod is correct R1 IPv6 routing. IPv6 unicast routing tapos exit dayon show IPv6 interface gigabit ethernet 00. Dayon makita nimo dito ang mga addresses nga ga-join sa iya. Kasi makita nimo 1 o 2 kung pasabot sa 1 o 2 pasabot duha ka buk na naka-join. Then i-verify din nato sa PC1 has an IPv6 default gateway. Ang IP config nato then sa IPv6 makita diri ang MAC address dito sa default gateway niya. So sunod kay verify nato ang correct path. Sa makita nato diri atong gamiton sa R1 mag-show IP route ta o show IPv6 route commands para ma-verify nato ang path gikan sa R1, R2 ug R3. Naro. Show IP route then begin gateway. So sa G000 nara iyang IP 10.1.0 dayon 10.1.10.1.1 dayon sunod kay IP writing table show IPv6 route makita nimo diri ang mga MAC address o mga gigabit ethernet. I-double check lang nimo ilang mga gigabit ani. Tapos sunod na to kay verify napoy mga methods IPv4 and IPv6. Ang gamit to directly connected networks, local host, static routes, dynamic routes, and default routes. Kani sa process ani destination address if nagmatch ba siya sa routing table, if no default route, kung ang default route niya nagmatch yapon, kung no discard packet, kung yes forward forward niya. Kung yes po ni siya diri mo paingon siya diri sa match with more than one entry, kung no forward packet, kung yes all entries have the same prefix length, kung yes i-forward niya ang packet using load balancing, kung no forward packet using longest matching prefix length. Tapos diri nga examine the functional based on the packet. Functional does not match an entry in the routing table, then the default route is used. If there is not a default route is configured, the packet is discarded. Then sunod, matches a single entry in the routing table, then the packet is forwarded through the interface that is defined in this route. Ikatulo, matches more than one entry in the routing table, and the routing entries have the same prefix length, then the packets for the destination can be distributed among the routes that are defined in the routing table. Matches more than one entry in the routing table and the routing entries have different prefix lengths, then the packets for this destination are forwarded out of the interface that is associated with the route. So, sunod, kay mag-verify tayo transport layer. Para sa pag-verify sa transport layer, i-ping nato siya kung ang pag-transport ba niya, kung success ba siya or dili. Diya ni mo makita sa ping kung mo abort pasabot nga abort or walay success rate 0%, pasabot nga nay mali naka-i-configure. Kung sakto mo abot ang success rate. Tapos kung pwede po another nga ma-troubleshoot na to ay ma-verify na to ang transport layer, kung sakto magamit ang telnet. kung ang telnet pagbutang nimo sa user o password dayon mo sulod siya sa router, it means nga na siya connection. If wala siya connection. So moto pag-verify telnet or ping. Sunod kay verify na tong ACLS sa diri nga table. To prevent the spoofing attacks, deny all the packet with a source address from entering serial. Ato siyang i-show IP access list. Ang sa verify nga ACLS, ikay magbuhat kung kinsa imo i-denied, kinsa po'y tagaan nimo permit. For example, diri nag-show access IP access list siya na ay mga 108 matches o 928 matches. Ang na-tsada sa verify or advantage sa verify ACLS, dili siya ma-spoofing attacks, dili siya basta-basta ma-hack. Kay kung kinsa to mga nga mga IP address nga mosulod, dili siya basta-basta makasulod kay naka-block siya, naka-denied siya. Iyarang ipasulod katong nay mga permit na mga IP address. Right? Then asunod ang verify DNS. Ang sa DNS i-verify nato siya paggamit sa pag-verify sa DNS. Example, magbuhatag IP host, IPv4 server, then mo ni atong DNS IPv4 server, then mo ning IP address sa DNS. Dayon i-ping nato siya IPv4 server kung ang DNS nimo katoy mong gibutang sakto to siya pag ping nimo sa R1, then pasabot success. Kung wala siya ni ping, it means na naisayop or naisayop sa keyword nimo pagbutang. Imo ra siya i-double check sa pamagi nga show running config. Naro, show running config. Pwede pod niya mag-set tag IP host. Dayon mo ni siya iping na to. And maura to. Nice. Thank you.